Regression and calculating residuals. This is really one of the most important things that we can do with statistics, because this is really how we use this to help us make predictions about data, make predictions about the future using data. So we could use statistics to make predictions about data just by using y equals mx plus b. This is called the line of best fit, and we call this regression. So a residual is a measure of how well our line predicts a data point, the vertical distance, just kind of the distance vertically between the point and our predicted point. Data points that are above this line will have a positive residual, while data points that are below this line will have a negative residual. But you really want a very small residual, because that just means, the closer it is to zero, the more accurate your prediction was. And that's the whole point of statistics, is just using data to make predictions about the future. So what's the math to calculate a residual? It's very easy. It's just a big subtraction problem. So to get a residual, all I need to do is calculate the difference. So I take the actual data point and subtract what our predicted data point was. And not even really the whole point, just the vertical distance. So just the y values. It's just a big subtraction problem, that's all. So let's look at an example here. Below in this graph, we have a scatter plot, and it's showing the change in a demand for a type of shirt at the store as the price changes. So you can kind of tell when the price is like $21, we have a high demand, and it sort of goes down as we raise the price up to $30. The price sort of goes down. And the sales manager, or maybe they have a statistician on staff, an analyst, something like that, they're using this formula. They're using this regression, line of best fit, to sort of model the data. So they're using y equals negative 1.81x plus 89.91 as the line of best fit. We call that regression. So here's what I'm asking you. First of all, what's the residual value when the price of a shirt is $25? So here's $25. It looks like the price for $25, the demand was 50. We sold 50 shirts when the price was 25. So let's see what that means. First of all, let's figure out what did we predict. So using the line of regression, let's just see what happens. So this was negative 1.81. The x value here was 25 plus 89.91. So really just using PEMDAS here, we're going to multiply this first. That's going to give me negative 45.25. And you might also see y hat with like an accent on top. It really just means the same thing. It's still going to be y equals mx plus b, but statistically we use this y hat for regression. Bring down the 89.91, and then we're just adding these together. So y is going to equal, adding these together, we would get 44.66. And again, we could use the y hat too. Really doesn't make any difference. It's just kind of splitting hairs, really. But you might see it either way. So on this, remember what we are going to do. This is the predicted value. So to calculate the residual, I'm just subtracting actual minus predicted. That's it. So what was the actual value? It was 50, right? When it was $25, the number sold was 50. So I'm going to do 50 minus our predicted value, 44.66. So go ahead and subtract those. It's going to give us 5.34. So not too bad. That is kind of a low residual. We are a little bit off. We're off by about 5. So that's going to be our answer for the first one. The residual, 5.34. Not too bad for that. It's a pretty good predictor of the data. let's check another data point. So the second question here, kind of doing the same thing. What's the residual value when the price of a shirt is $21? So again, we're using the same line of best fit. This is negative 1.81 times, here we're going to look at 21. So 21 is right here. I tried to pick points that are right on the graph so they're not too hard to deal with the decimals or anything, estimating, anything like that. All right, so really just the same regression line of best fit, except now we are using 21 instead of 25. So let's go ahead and PEMDAS this. Negative 1.81 times 21 is negative 38.01. And we're going to add in this 89.91. And that gives us 51.9. All right, so our Y hat value, or our predicted value, 51.9. And again, we're just doing that same thing. Actual minus predicted. So what was the actual value for $21? It was 56. And we'll subtract the predicted value, 51.9, and that's going to give me 4.1. So an even smaller number. This is even better than this. Again, the smaller our residual is, the better the model is. So this is 4.1. All right, and that's basically it. The last part here is just asking what's the y-intercept. This is just y equals mx plus b. So this would be the y-intercept. If I sketch the line, we kind of go up here up to 89.91. The graph is a little bit off because you can see we don't go all the way to 0. We kind of skip from 0 to 21, or here we skip from 0 to 42. So the graph is a little bit off, but it doesn't matter. We just need to use this. This is 89.91. So that just means that the number of shirts sold would be, all right, so going off the graph, it does look like the y-intercept would be 58, but again, this graph is kind of cut short. There's some pieces missing. Really, it's just going to be 89.91. Really, let's just say 90. Let's round that up to 90. You can't really sell 0.91 of a shirt. So if prices were lowered all the way, if I just got rid of this entire slope in X, I would still have that 89.91. And rounding that up, we would sell 90 shirts, even if we lowered prices all the way. All right, here's another good problem. So kind of the same thing here again, but this one's going to be a little bit easier to read the data from. So a toy factory collected and analyzed their data on sales starting in the year 2010. They produced a scatter plot that models the cost to run the factory in dollars based on how many toys are produced. So from this data, you can see these data points. They have a line of best fit, and they're using this to predict that line of best fit. Or here we could also use, just like the last one, we could say C hat with that accent mark on top to talk about regression in the line of best fit. It really doesn't matter for us. We're more concerned with the math here. You just might see it either way, though. So first of all, let's see what we're being asked here. The cost of factory production decreases by about how much after every toy that's produced? So we're decreasing by negative 1.2. Really just the slope here. We're going down by about negative 1.2 each time. So negative 1.2. When 100 toys are produced, the cost to run the factory is how much? So let's see what our model predicts. Let's use negative 1.2. times 100 plus 230, and just PEMDAS this. So negative 1.2 times 100 is negative 120. And then adding in that 230, it's going to be 110. All right, so when we produce 100 toys, our predictive model is guessing about 110, which you can kind of see that from the graph here, right? Here's 100. Looks like it's kind of going down here to 110. Let's see, what's the y-intercept? We can just get that straight from the equation here. Looks like it's 230 is the y-intercept. So that would mean that the factory costs that much. It costs 230 to run, even when no toys are being produced. So even when there's nothing being made, it's going to cost at least $230, plus whatever toys are being made. All right, and then our last thing here, what's the residual value? Let me make some space. So what's the residual value when 10 toys are produced? So let's go ahead and figure out what's our predicted value here. It's going to be negative 1.2 times 10 plus 230. All right, and then the actual data point for 10 looks like it's right about here. So it should be about 210. Hopefully we get something around there. I can kind of already tell it's not going to be that because look at where the line's going. I can already tell it's not going to be on the line. Let's see what we get. Negative 1.2 times 10 is negative 12 plus 230. And then just subtracting these, negative 12 and 230, putting those together, you're going to get 218. All right, again, to get that residual, we're just subtracting the actual value minus the predicted. All right, so the actual value should be 210. Our predicted value was 218. So yeah, this one looks like it is going to be a little off. We are going to get negative 8 for that. It's negative because it is below that line of best fit. So negative 8, what's the residual value? Negative 8. So this line is a pretty good predictor for most of these data points. These are not going to be predicted very well because they would have high residuals. All right, so that's basically it. Regression is just using y equals mx plus b to make that line of best fit, and then calculating the residual. We're calculating the difference between the actual data point and our predicted data point. And just the thing to remember here is the lower the number, the smaller your residual, the better our statistics are. All right, I hope that helps you out. Have a great day.